Imagine you are given stock prices for each day and your goal is to make the maximum profit with just one buy and one sell. Sounds simple, right? But many people solve this inefficiently. In this video, I'll first explain the brute force approach, then we'll optimize it using the greedy algorithm, and finally implement the optimal solution step by step. So please be with me. And hi everyone, so this is your Common Techie and this is day 5 of my DSA Growth Series. So let's understand the problem. You are given an array called prices, where price is of I represents the stock price on the ith day. Your goal is to maximize profit by buying on one day and selling on a future day. Important constants: you must buy before you sell. uh, I mean, that is what happens in real life as well, and you can only make one transaction. So let's look at the example. Prices, we have the array prices where the index the values are 715 715 3 6 and 4. So if you buy at price 1 and sell at price 6, your profit is 5. That's the maximum possible profit. If proper prices keep decreasing like 76431, then no possible profit is possible. So answer is 0, as we can see here. So let's first think about the brute force approach first. We can try every what we can do is like we can try every possible pair of days. For each day, assume we buy the stock, then check all the future days to see when the selling gives the maximum profit. So for this brute force approach, we use two loops: outer loop, which will have the logic of buying day, where we buy the stock, and inner loop where we sell the stock. So for every pair, we calculate profit is equal to sell price minus buy price. So here in this approach, we can keep the track of maximum profit, and anyhow time complexity would be around O of n square, because for every element we check all future elements. This works, but it is inefficient for larger inputs. So let's see how we can optimize this. We need to maximize. So profit is equal to selling price minus buying price. To maximize profit, we want the minimum buying price and the maximum selling price after that. So instead of checking all the pairs, we track minimum price seen so far and maximum profit seen so far. This is where greedy algorithm comes. So what is greedy algorithm? In simple terms, greedy algorithm means making the best decision at each step, hoping it leads to the optimal overall solution. So anyhow, in this problem, at each day we update minimum price so far and maximum profit so far. So we make the locally best decision, which leads to globally optimal result. So like in each iteration, we what the value we get, we just assume that this would be the answer. So as we go on the iterations of the loop, we will get the best global possible answers. So this reduces the time complexity for from O of n square to O of n. So it's better if we start coding and we'll understand better with an example. So I'll just start here. Yeah. So since we want one minimum price, and initially what we can do is like we can set a maximum value for that price, as anyhow our minimum would be lesser than this in future. So yeah, and in max profit we can take. So profit anyhow, it's like the least value could be 0, so we can initialize this at 0. So we need to start the for loop first. So first we'll check the minimum price condition. So we'll do nothing but check if my prices of I is less than min price. So we'll initialize this value to the min price. So min price is equal to prices of I. Also else now we'll store the profit if profit is equal to prices of I. Now that we have got the min prices of I in, so we'll calculate the profit locally. I'll explain more about the code after some time. So this is nothing but we are checking if for the max profit, if our current profit is greater than the max profits, then we'll initialize our current value to the max profit. It's a simple check, simple checks with my typo. So yeah, this is it, and we can just return the max profit. So let's understand this step by step. So at first we initialize minimum price to highest possible value because we need the minimum price later. So it anyhow can't be the maximum value. So just for here we are initializing it, and max profit as 0 because anyhow minimum profit would be 0. So here we are starting from the least value. So now we iterate through the array. At each step, if current price is less than minimum price, we update the minimum price. Otherwise, calculate profit. So profit is equal to current price minus minimum price. So if profit is greater than max profit, update the max profit. Finally, return max profit. So we'll just do a dry run of this. So we'll take this example 715364. So like step by step, the first minimum price value would be 7. After that minimum price would be 1, and profit would be 4, and then profit would be 6 minus 1, which is like our maximum profit would be 5 here. So final answer, uh, like we need to buy the stock at 1 and we need to sell the stock at 6. So final answer or final profit would be 5. So yeah, that is how our code works. And time complexity, as we can see, is like we are iterating the array only once, so it is O of n. And so let's summarize. So brute force approach would take around O of n square time complexity, whereas our greedy approach will take around O of n time complexity. So greedy works because we track minimum price and maximum profit at each step. So this is the optimal solution. So we'll just try to run this code once. And we got a typo here. We forgot to add minus here. Yeah, so as we can see, both the cases are passing. We'll try to quickly submit this problem. So yeah, as you can see, it beats around 99.76%. So yeah, this is around this is around the most optimal solution you can find. So yeah, if you found this helpful, subscribe to follow my DSA growth series where I solve problems daily. So see you in the next problem. Bye bye.